In this example, we're asked to solve the following system of 3 equations and 3 variables. 2x plus y equals -4, -2y plus 4z equals 0, and 3x minus 2z equals -11. So this one might look a little different than the previous example in that it's missing the variables. Each equation is missing a variable. The first equation's missing z, the second one's missing x, and the third one's missing y. Well, it turns out these are actually a little more simple than the kind with containing all three variables, because remember, the method we use is elimination. Well, so if we're trying to pair up equations to eliminate a variable, each one actually already has one of the variables eliminated. So for example, the first equation is missing z. So if I pair up the second two equations and eliminate z, I can use that first equation just as it is. So that's what I'm going to do. Since the first equation's missing z, I'm going to pair up the other two to eliminate z from those. So I'm going to pair these two up, and I'm going to leave this one just as it is because it already has the z's eliminated. So I'll rewrite the second and third equations, -2y plus 4z equals 0, and 3x minus 2z equals -11. And when you write these, you want to kind of keep the variables lined up. So x and y, they're not like terms, so I'm going to put them in separate columns, and I'll put the z's in the same column and the constants in the same column. So if I want to eliminate z from this system, I'll have to get, if this is a 4 here, I'll have to get this to be a -4, and then we could eliminate those z's. So I'll multiply my second equation here by 2. So I'll rewrite the first equation, -2y plus 4z equals 0. And then the second equation, 3x times 2 is 6x. -2z times 2 is -4z. And then -11 times 2 is -22. So now I'm going to add down the columns, which are the like terms. Well, there's nothing in this top term here. It's just the 6x. So I'm just going to bring down my 6x. And then I've just got my y term here, no y term here, so they'll just bring down that -2y. And as we wanted, the z's are eliminated because 4z and -4z add up to 0. And then if I add 0 and -22, I get -22. So now I've made an equation of just two variables, and specifically x and y, which will correspond to the first equation, which has just two variables, x and y. So now I'm going to solve the system with the 2x plus y equals -4 and the 6x minus 2y equals -22. So I'm going to rewrite these. So I'll rewrite my first one, 2x plus y equals -4 and 6x minus 2y equals -22. So now with this system, I could either eliminate the x's or the y's, but since there's no coefficient on this y, the coefficient is 1, this will be the easiest. So if I have a -2y here, I can multiply this top equation by 2 to get the opposite here of a positive 2y. So I'll multiply here by 2. So then my top equation, 2x times 2 is 4x, y times 2 is 2y, -4 times 2 is -8, and then I'll rewrite that second equation, 6x minus 2y equals -22. So now I'll add down the columns, 4x and 6x give me 10x. As we wanted, the 2y and the -2y add up to 0. We've eliminated y. And then we've got -8 and -22, which will give us -30. So then we can just divide each side by 10 to get that x, so we're going to get x equals -3. So there's the first of our three variables. Now we can take this x and substitute back into one of these two equations in two variables. So either one of these, I'm going to choose the first one because, again, there's no coefficient in front of the y, it's just a 1. So I'm going to plug in, so 2 times -3 plus y equals -4. So I've got -6 plus y equals -4, and add that 6 to both sides so I get y equals 2. So now I've got two of the three variables, and I just need to take the x and the y and use them to substitute into one of the original equations that contains a z. So if I look at my original ones, I could use either the second equation or the third equation. They both contain z's. In my notes here, I'll use the second one. So I've got negative 2 times y, so put a 2 in for the y, plus 4z equals 0. So we've got negative 4 plus 4z equals 0. And I can add that 4 to both sides, so I'll get 4z equals 4, and then divide both sides by 4 to get z equals 1. So our solution is the ordered triplet, negative 3, 2, 1. And remember, to check our solution, we must substitute back and make sure that this triplet satisfies all three of the original equations. So for our check, the first one, we want 2x, so 2 times negative 3 plus 2 for y, and we'll see if that equals negative 4. So we've got 2 times negative 3 is negative 6 plus 2 is negative 4. That's good. And the second equation, negative 2y, so put the 2 in for the y, plus 4 times 1 for the z, and we'll see if that equals 0. So I've got negative 2 times 2 is negative 4, plus 4 times 1 is 4, and that does give us 0 equals 0. And then finally the third equation, 3 times negative 3 for the x, minus 2 times 1 for the z, equals negative 11. So we've got 3 times negative 3, negative 9, minus 2 times 1 is 2, and that does give us negative 11. So negative 11 equals negative 11. So we have verified that our ordered triplet, negative 3, 2, 1, is the solution to this system.